Okay. So, we will come back to this another one. Here you have to find out your R in, that is your R Thevenin, right. Between R in means R Thevenin, but here one dependent current source is there. If dependent current source is there, so better you put one dependent or what you call one independent current source or voltage source. Here we will put one independent current source, right. Here say here we can put one independent current source, it say it is 1 ampere, because right, and you have to see the voltage here V 0, and this independent current source current I 0 is equal to 1 ampere, say I 0 is equal to 1 ampere, that means this voltage is your V 0, that means your R input, that is your R Thevenin is equal to your V 0 by I 0. We will take I 0 is equal to 1 ampere, say. Therefore, let me clear it. So, now if you look into the circuit, all explanation are there, but directly we are going here, I told you. So, put 1 ampere your what you call and the independent current source here. So, this voltage, actually this voltage your V, right, this voltage is taken V and current is I. So, therefore, R Thevenin is equal to will become V by I. So, we have to finally you have to get the V. So, question is that, so if I is equal to, we have taken 1 ampere. So, V by I is equal to V by 1 is equal to V. I mean, if we get the value of V, then we will be knowing what is your what you call that your R Thevenin. So, let me clear it, let it move little bit up. So, in this case what you can do is for this circuit, this is common node, this is your anyway common node. So, here your I is equal to 1 ampere current is entering, this is a common node, and this voltage V means from nodal analysis this is a common node. So, V and V, because this is your nothing is there, this is a common node. So, V and V meaning is same here, right. So, that means that this I is entering into that your what you call into this, if you apply KCL here, then I is entering. So, in that case and I is equal to 1 ampere. So, this is your I is equal to 1 ampere. So, 1, right. Another current 3 by 2 I x is also entering. So, plus 3 by 2 I x, right. These two current both are entering and is equal to this current is leaving through this branch, it will be V by 25. So, here it is V by 25. Another one voltage V is here also and this 50. So, here it will be leaving this thing, it will be V by 50, because this is actually what you can do is you can ground it, right, like nodal analysis we are making. So, here it is V by 50. So, V by 25 plus V by 50 is equal to 1 plus 3 by 2 your I x, but question is this I x is given, actually this is your I x. So, I x actually is equal to your V by 50, right. So, this is actually I x and this is actually V by 50. That means, in this expression you put also 3 by 2 into V by 50, then you will get the solution for V. So, let me clear it. Hope you are understanding this, right. Hope you are understanding this. So, this is, if it is so, then we put I x is equal to V by 50 and you solve it, you will get V is equal to 33.3 volts and R Thevenin is equal to, told you it will be simply V. So, it is 33.3 ohm, right. Next is your the example 18, the find the Thevenin equivalent of the circuit shown in figure 46. So, you have to find out Thevenin equivalent, that is VOC is equal to V Thevenin and R Thevenin. So, this is open. So, no current is flowing here, but at the time of computation of VOC or V Thevenin we have to apply KVL. So, we have to obtain your what you call V Thevenin, right, and no current is flowing here because this is open and this voltage is V, means this is a common terminal. So, here voltage is V, right, and this is 100 volt. So, no electrical element here, means this point voltage is 100 volt, and if I say it is grounded. So, with respect to the ground, so this is, there is no electrical element. So, this point voltage is 100 volt, right, and this is actually a common node, no electrical element is there. So, if it is so, then if you take the direction of the current here leaving this node, right, it will be V minus 100 by 10. current flowing through this 10 ohm resistance will be V minus 100 divided by 10. This is the current flowing through this 10 ohm resistance, this outer direction, right. Similarly, here also it will be V by 40, this will be V by 40, right. And another thing is that this is a current source is here, one current source is here and it is 20 ampere, that means current flowing through this is 20 ampere. So, it is also leaving, right. So, that means your what you call, if you now if you apply your this current also leaving, that V minus 100 by 10, this current is also leaving, this current is also leaving. That means, if you apply KCL here, this is a common node. If you apply KCL, because every time I am not bunching it together, it is understandable, it is a common node. So, that means, it will be V minus 100 by 10, because all currents are leaving, this is leaving, plus V by 40 plus this 20 ampere current is also leaving, because this is a current source, right, is equal to 0. If you solve this, you will get the value of V, right. So, let me clear it. So, if it is so, then V is equal to whatever I wrote, V is equal to, you will get minus 80 volt, right, minus 80 volt. Now, V you are getting minus 80 volt, that means this voltage, this is V, same thing. Suppose minus whatever we have got, we will write, this is minus 80 volt and this is your plus minus whatever is there, this. Now, we apply, you apply KVL like this. So, if you are moving like this, you are encountering minus terminal first. So, minus 20 plus this is V, this is your plus, this is plus minus. So, plus minus same thing we are writing, plus V, right, encountering minus terminal first, V Thevenin is equal to 0. That means minus 20 and V is equal to minus 80 is equal to V Thevenin. That means, V Thevenin is equal to minus 100 volt, right. So, same thing, it is calculation is there later, first we have to understand. So, this is actually we are getting V of Thevenin is equal to minus 100 volt. Now, so figure 47 is a circuit with the voltage sources replaced by short circuit and the current sources by an open circuit, right. Now, this there was a current source here, because we have to get R Thevenin, we have to get R Thevenin. So, this current source is open and this voltage source here, it is short circuited, right. So, there will be no effect for this one, it is completely isolated, right, nothing is there. And thing is, this 5 ohm and your this it is short circuit, that means, this 5 ohm actually has no value, right, because if for your understanding only, suppose if I take R is equal to 0 ohm for this branch. So, 0 ohm and 5 ohm they are in parallel, say for your understanding. So, 0 into 5 by 0 plus 5 is equal to 0 ohm. So, that means, this 5 ohm has no effect, right. So, let me clear it. So, that means, if you try to find out that that what is the then what is the equivalent one. So, just for your understanding, I am somehow I am making it here, say this is your say 5 ohm, this is your 1 amp, one terminal 1, then this is your what you call 40 ohm and this is your 10 ohm, right, and this is connected and this is your terminal 2 and this is your R Thevenin. That means, 40 and 10 are in parallel, with that 5 is in series. That means, your R Thevenin will be equal to 5 plus 10 into 40 divided by your 10 plus 40, right. That means, 5 plus 8 is equal to 13 ohm, right, because 400 by 50 it will be 8 ohm plus 5 is equal to 30 ohm. So, let me clear it. So, that means, this one will be 13 ohm and this is your Thevenin equivalent circuit, right. So, next one is another one is that so this is, hope you have understood, this is V Thevenin, this is R Thevenin. It was asked to find out V Thevenin, we got only one thing I have to tell you here, we got V Thevenin is equal to minus 100 volt, right. That is why this plus polarity is at the bottom and minus is here, right. So, that is why I have written V is equal to 100 volt. So, there should not be any confusion and this is your 13 ohm. So, let me clear it. So, next is you determine the current through 10 ohm resistor of the circuit shown in figure 49 using Thevenin's theorem, right. You have to find out the current through 10 ohm resistance. That means, here you have to find out the current through 10 ohm resistance. That means, you have to open 10 ohm resistance to get the V Thevenin, and similarly you have to find out the R Thevenin there. So, and this is 36 volt, and this is no other thing is there, this is no electrical other element, just in between this terminal, this 36 volt source is connected. So, first you take it, take 10 ohm resistance open. So, if we open it, the circuit looks like this. If you open it, so this is 1, this is 2. So, this is my VOC is equal to V Thevenin, right. And for R Thevenin, that voltage source is shorted, this voltage source is shorted here, this voltage source is shorted here, right. So, it is shorted, this is for R Thevenin, and this is for your what you call that your V Thevenin. We have to solve this circuit for V Thevenin. Now, before moving further, if you look into that, this current, right, this suppose this current, this is open, this side is open. So, basically from this source the current I1 is flowing, this current, this is open, nothing is going. So, this I1 is coming here, this is your I1. Now, part of the current I1, I2 is flowing like this. So, in this circuit it is I1 minus I2, right, and finally I1 minus I2, and that this I2, this side is open. So, same I2 current is flowing here, right, and finally when they are meeting it here. So, finally this I1 current will return to the source, right. So, this way first you have to make the circuit. So, after this you have to solve for your what you call I1 and I2. Now, question is that if you look into this circuit, let me I hope you have understood this, right. Now, question is, let me clear it. So, as your this 20 ohm and 30 ohm, it is in series. So, 20 plus 30 is equal to 50 ohm, right, and another 50 ohm is here. That means, this 20 plus 30 50 ohm and this 50 ohm, they are in parallel. That means, 50 and 50, both 50 are in parallel. That means, equal amount of current will flow through both. So, let me clear it. That means, whatever current is flowing, your this I2 current is flowing here, right, through 20 and 30, both are in series, and I1 minus I2 also flowing to 50. That means, I1 minus I2 is equal to I2, because both this current and I2 current both have to be same, because both are 50-50, because 20 plus 30 50 ohm. That means, 2 I2 is equal to your I1. This is, that means, I1 is equal to I2 is equal to your I1 by 2, right, because it is a current division, right, it is a current division. So, that means, here also flowing I1 by 2, here also effectively flowing I1 by 2. Once it is done, so easily you can your what you call your what you call apply your KVL, right. For example, you can apply KVL like this, you can apply KVL like this. That means, if it is I1, then this current will be basically I2 is equal to I1 by 2, and here I1 minus I2 means it is also I1 by 2. So, easily you can get it. So, if you apply KVL here, it will be look your what you call, if I make it like this 40 I1, right, this one, and here it is your this current is actually I1 by 2, because current division is there. So, plus 50 I am writing like this, plus 50 into I1 by 2 minus 36 is equal to 0, from which we will get what is I1, right. So, if you get I1, let me go through this, let me clear it fast. So, if you go through this, then you will get, if you solve the way I told you, I1 is equal to, you will get 36 by 65 ampere, and I2 is just I1 by 2. So, it is 18 by 65 ampere that you got. So, I1 I2 you have got, then you easily you can find it out that what is my V Thevenin. So, this is plus, this is minus, again I am not marking it, it is understandable. Now, if you apply your KVL here like this, if you apply KVL here, right, anticlockwise. So, it is 40 I1, right, plus we are moving like this, plus 20 I2 minus V Thevenin is equal to 0, right. So, put I1 value, I2 value, you will get V Thevenin. So, that is whatever we have done it here. So, whatever we have done it here, it will be coming 360 by 13 volt, right, that is my V Thevenin, 360 by 13 volt. Now, you have to find out what is that your what you call that R Thevenin. So, if you read the circuit like this, this terminal is 1 and this terminal is 2, because this is 1, this is 2, this is 1, this is 2. Now, these two point is a common point. So, basically the circuit I am trying to make it like this, this is 2, right, this is 2 and this is your 20 ohm resistance, right, this is your 20 ohm resistance. Now, basically this 40 and 50, this 40 and 50 actually are in parallel. So, this is 40 ohm and this is your 50 ohm, right, and this point is your, this point is 2, sorry, this point is 1 and then your what you call this 30 ohm is connected like this. I mean what I did, I bring this point here, right, that means 40 and 50 in parallel, because no other electrical element is here. So, 40 and 50 in parallel, right, whatever it will come with that 20 ohm is in series, whatever it will come with that again 30 are in parallel to this. That means, if I make it like this, it will be actually whatever it comes 50, I am making like this parallel to 40, right, whatever it is, plus this 20 will come making on it only, plus 20 will come, whatever will be there you add it with that 30 again is in parallel to that, right, whatever it will come you find it out, right. So, that is your what you call, that will become your R Thevenin. I hope you have understood this, right. So, that means let me clear it. So, what I have done it here, same thing. So, I have just put directly that 40 and 50 are in parallel, with that 20 is in series and along with that 30 ohm again in parallel. So, it will become your 228 by 13 ohm, right, and I will be V Thevenin, because it has been asked to find out current through 10 ohm resistance, 10 ohm resistance. So, your circuit is not V Thevenin, R Thevenin is not shown directly given, the I is equal to V Thevenin by R Thevenin plus 10. So, your R Thevenin is becoming this much and V Thevenin we got 360 upon 13. So, ultimately it is 360 upon 358 ampere, approximately 1 ampere, that is I, right. So, let me clear it, sorry, let me clear it. So, I hope you have understood this, right. You will not get much difficult one than this one. So, just for your understanding only, I have taken varieties of problem, but remember for AC circuit, see these too many problems will not be taken, because time is restricted. So, example 20, obtain the current in 2 ohm resistor of the circuit shown in figure 51. Use Thevenin's theorem, also superposition also will use to get the Thevenin voltage. So, in this case you have to find out what is that current through 2 ohm resistance, that means what is the current through 2 ohm resistance. So, you have to take it off first 2 ohm resistance, right, and you have to find out R Thevenin and V Thevenin. So, go to the equivalent circuit. So, in this case what will happen, that 2 ohm resistance is taken off. So, it is open, 2 ohm resistance is open and we have marked one voltage here V A, another voltage is V B. V A means this voltage, this is your V A and this voltage, say putting it here, this is V B, right. If you assume it is ground, then nodal analysis you will apply, right. So, question is that these two voltage have been taken, but you have to ultimately obtain V Thevenin, and this is a 30 volt source, one 9 ampere source independent source is there, one 4 ampere independent current source is there, two independent current source is there and one independent voltage source of 32 volt is there. Now, what you do is you apply KCL at node at this point. If you apply KCL, so this 9 ampere current is entering into this. So, you can make 9, right, then you your this 9 is entering, then it is 5 ohm resistance, this voltage is V A. So, this current is leaving. So, it is V A by 5, right. So, 9 is equal to, you can make V A by 5, this current is leaving, and another current if we take in this direction, this 4 ohm resistance is here. So, it will be your making it here, it will be V A, this voltage is V B minus V B divided by your 4, because this 4 ohm resistance. So, plus V A minus V B divided by 4, this is V A by your 5, this is your 9 is equal to V A by your 5, right. So, it is V A by 5 plus V A minus, this is one equation, this is one equation you will get. So, let me clear this one. So, this is later equations are there, right. Now, another one is, if you apply your what, hope I have not missed anything, if you apply your what you call KCL at node B. So, this current we saw it is entering V A minus V B by 4, because this 4 ohm resistance, current through this is V B by 10, right, and this 4 ampere current it is entering. So, it is basically 4 plus V A minus V B divided by 4, because this current is also entering and this current is leaving, is equal to your V B by 10. So, two equations we got, and you can solve using two equations V A and V B. Hope I have not missed anything, and there is no current flowing here, because this is open. So, no current is flowing here right, sorry. So, those two equations I have written here. Here it is one equation at node A, another equation at node B, and solve this equation 1 and 2 for V A and V B. If you do so, you will get V A is equal to 830 upon 19 volt and V B is equal to 810 by 19 volt. Therefore, your therefore, you apply your what you call that your KVL for getting the Thevenin. So, this voltage is V A. So, this is actually arrow means plus, this is V A, and this voltage, this is your V B, right. If you assume this is grounded, so that this is plus minus and this is also plus minus. So, if we apply KVL like this in this mesh, then if you move like this, it will be minus 32, because minus terminal is coming first, plus V A, because V A is coming first, right. Then here it is minus, right. So, minus V B, right, and there it is minus V Thevenin is equal to 0, right. That means, V Thevenin is equal to V A minus V B minus 32, right. So, that means, let me clear it. So, that means, your whatever you have wrote, that V A minus V B minus V Thevenin minus 32, what I wrote, V Thevenin is equal to V A minus V B minus 32 is equal to, I wrote there. So, you put all these things, you will get V Thevenin is equal to minus 30.947 volt, right. So, minus means, so you will make the polarity, it will be at the downwards, right. And similarly, for R Thevenin, that your R Thevenin, that this one voltage source is here, it is shorted and current source is open, right. So, basically what happened, this 5 and 10 ohm are in series. So, it is 5 plus 10 is equal to 15 ohm. So, this is open. So, 5 and 10 are in series, with that 4 ohm is in parallel. So, R Thevenin will be 15 into 4 divided by 15 plus 4, whatever it comes, that will be your R Thevenin, right. Because this 1 and 2, I mean it is something like this, this is your 1, these two are open, this is 1 and this terminal is 2, this is 1, right. So, this is actually 4 ohm and here it is 5 plus 10. So, here it is actually 15 ohm, right, and this is 1 2. So, 4 and 15 are in parallel. So, whatever it comes. So, in this case, so R Thevenin will coming 60 by 19 ohm, right. So, therefore, Thevenin equivalent you will be your if you look into this, that it is plus, because V Thevenin was minus 30.947. So, it is plus is here bottom here, right, and it is moving like this, and this is R Thevenin, with that 2 ohm resistance you connect now and you will get the value of the current. So, I is equal to V Thevenin by R Thevenin plus 2 ohm, this 2 ohm, right, and put all this value. So, it is approximately 6 ampere. So, this is the answer. Right. So, now next one is you obtain the Thevenin voltage shown in the circuit of this thing. Now, what Thevenin voltage also you can obtain by using superposition theorem, because you have 3 sources. Just to show you something, 3 sources, one voltage source to current source, you consider only one source at a time. Same example, the same example you obtain Thevenin voltage using your superposition theorem, because you have 3 sources, take only one at a time just to show you, right. So, in this case your if it is so, then in this case first we have considered the voltage source, and your this only voltage source, this current 2 sources are turned off, and current is here I 1 I 2. You solve for I 1 and I 2, later I will give you the solution. So, otherwise it will consume more time. So, I 1 and I 2. So, next one is that you consider only 9 ampere current source. This is your 9 ampere current source, right, this 9 ampere current source, and this voltage source is shorted and this current source is open, only one at a time, and current is here I 3 and I 4. You have to solve for I 3 and I 4. Next is your this one that next is this one, that your 4 ampere is there current source, but other two it is shorted, voltage source is shorted, voltage source was here and this is current, right, this is open. So, this is I 5 and I 6, that all these things you have to obtain. So, all the A, B, C, 3 circuits are there, A, B, C, everything is written here. So, it is just to show you the superposition theorem. That next is when you solve it, look from figure A, that is all these things solutions are given to you, right, and similarly figure B, figure A it is given I 1 0, I 2 0. Similarly, figure B, your I 3 is equal to 6.63 ampere, I 4 is 2.37 ampere. You please solve it. Everything I have written here for you, but you please solve it. And similarly, for figure C, I 5 is given, we got 2.11 ampere and I 6 1.89 ampere. Now, that current flowing through 5 ohm resistance, that is I 5 ohm we are writing, I 1 plus I 3 plus I 5. You just add it, superposition 8.74 ampere. Similarly, current flowing through 10 ohm resistance here, it is I 2 plus I 4 plus I 6, it is coming 4.26 ampere. So, V A is equal to 5 into current flowing through I 5 your 5 ohm resistance, that is I 5 ohm we are writing, that is 5 into 8.74, 43.7 volt, and V B is equal to your 10 into I 10 ohm we are writing, that is current flowing through 10 ohm resistance. So, 10 into 4.6, so 42.6 volt. Therefore, V Thevenin is equal to V A minus V B minus 32. Initially, I have written for you. So, put V A, V B and you will get minus 30.9 volts. Same thing using superposition takes lot of time, right. Next is your Norton theorem. So, Norton theorem, this is Norton's theorem. So, Norton theorem states that a linear 2 terminal circuit can be replaced by an equivalent circuit consisting of a current source I n and parallel with a resistor R n. In the Norton circuit case, R Norton and R Thevenin, they are same. At the beginning I am telling that R Norton is equal to R Thevenin, that begin thinking. I think Thevenin gave this thing in 1800, I think 92 we gave, and Norton probably in 1933 or 37, exact I have forgotten exact thing, and I mean that means nearly after more than 40 years, right. So, sometimes the source transformation we call Thevenin Norton's transformation, because Thevenin gives one voltage source and resistance. When you transform into Norton, it will be a current source and resistance is in parallel. In Thevenin, resistance is in series with the voltage source, right. So, the philosophy is that your, so where I n is short circuit current through the terminals, that will give, and R n is equal to input or equivalent resistance at the terminal when the independent sources are turned off, right. It is same like your R Thevenin is equal to R Norton. So, that means R Norton is equal to R Thevenin. So, idea is for Thevenin's theorem we got open circuit voltage. In this case we will get your what you call that short circuit current. That means, this is a linear 2 terminal circuit, right. This is a linear, this is your I Norton, actually I Norton is equal to I short circuit, right, and Norton resistance is nothing but a Thevenin resistance is same, right. So, I Norton ISC means if you short circuit it, and if this is your short circuit current, so I Norton will be equal to ISC, right. So, in this case what we will do, we have to find out that what is short circuit current, right, and then we have to find out Thevenin resistance and this Norton and your Thevenin Norton resistance and current source both will be in parallel, right. So, that is just in the case of Thevenin it was open circuit, in the case of Norton it will be your what you call it will be in short circuit, right. So, and then we have to find out short circuit current ISC, that is nothing but is equal to I Norton, and for R Norton is say identical to your R Thevenin same. So, let me clear it, right. So, with this, so all this write up is here, you can go through it. So, whatever I told I Norton is equal to ISC, right. So, that means whatever I told that terminal 1 to short it and make it ISC is equal to your I Norton, right. So, that is your what you call short circuit current. So, finding Norton current, that means I Norton basically is equal to V Thevenin by R Thevenin. The idea is sometimes we call that it is basically Thevenin Norton transformation. Suppose Thevenin's theorem, making it here only, suppose Thevenin theorem, this is your V Thevenin you got, right, this is your V Thevenin you got, and this is your R Thevenin, this is your R Thevenin, and this is terminal 1 and this is terminal 2, this is your R Thevenin, right. And if you go for source transformation, so it will be your I Norton, right, and this will be your basically R Thevenin is equal to R Norton, both are same, and this is terminal 1 2. That means, I Norton is equal to source transformation V Thevenin by R Thevenin, right. So, sometimes we call that it is basically your Thevenin's Norton's transformation, right. So, because it is voltage source is in series with resistance, there it will be current source in parallel with the resistance. So, all these things are written here, all these things are written here for you, you go through it, but I have told you what is the essence of it, right. So, all these things and same way the way you got Thevenin's your resistance, same way Norton resistance. So, V Thevenin is equal to VOC and I Norton is equal to ISC. So, R Thevenin basically V Thevenin by ISC is equal to R Norton, VOC is V Thevenin. So, R Thevenin is equal to basically your V Thevenin by ISC, you will get the your what you call that Norton resistance, same philosophy, right. So, with this just one example, determine Norton equivalent circuit of the circuit shown in figure 58. So, you have to get the Norton equivalent circuit of this one, 2 ampere independent source is there and a 10 volt source is there and 4 ohm, 2 ohm, 5 ohm and 2 ohm resistance are there. To get the Norton equivalent circuit, first what you do, R Norton is equal to R Thevenin, that means current source is open and voltage source is shorted, right. That means, if you now if it is like this, then you can see that this is open. So, 2 ohm, 4 ohm and 2 ohm, these 3 resistors are in series. So, total will be 2 plus 4 plus 2 is equal to 8 ohm, and with that 5 is in parallel. So, R Norton will be is equal to your 8 plus 5. So, it is 40 by 13 ohm. So, R Norton is nothing but R Thevenin, same thing, the way you get Thevenin same way you got R Norton, it is same thing, right. Just 1 minute, then you come to this your you have to find out the short circuit current. So, what you do in Thevenin equivalent circuit, 1 and 2 were open, but here it is shorted and we got ISC. So, this is the short circuit current ISC, right. And in this case we are here we are taking I1 and it is I1 also, this basically it is 2 ampere going upwards. So, I1 is equal to 2 ampere, right. So, in this case if you apply your what you call, this is your 2 ohm. So, in this case if you apply your KVL, suppose if I go like this and I apply your KVL. So, this current we are taking your what you call that your short circuit current, that means here no current, here in 5 ohm this thing resistance, actually it will be ineffective because this is shorted. So, current will flow like this. So, that is why this is shown like this, because it is shorted. Now, you apply your what you call KVL here, you will get your what you call I2. If I write it for you, it is 2 plus 2 ohm plus 5 ohm plus 2 ohm. So, 2 plus 5 plus 2. So, it will be 9 I2 moving like this, 9 I2, and then your I2 basically is equal to ISC, because this is ISC you have taken, I2 is equal to ISC. then minus 10, because encountering minus terminal plus, then your plus 4 into I 2 minus I 1 is equal to 0, because we are moving like this. So, 4 into I 2 minus I 1, and I told you earlier I 1 is equal to 2 ampere. So, put I 1 here is equal to 2 ampere, and then you solve for I 2, and this is, and second circuit is given for your what you call for Thevenin. Here it is given I 3 and I 4, VOC is equal to, just for the purpose of comparison, V Thevenin. Now, you can easily solve it after solving so many things. So, Norton is given, I told you 3.007, I told you, right, how it will come, and similarly I 1 I told you 2 ampere, and I gave the equation how to get it, 8 I 2 minus 4 I 1 is equal to 10, but I 1 is equal to 2. So, you will get I 2 is equal to 2.25 ampere. That means, I told you also I short circuit is equal to I 2 is equal to 2.25 ampere. Alternatively, we can determine I n is equal to V Thevenin by R Thevenin, same thing, right, because source transformation I told you from Thevenin Norton transformation actually. So, I told you I n is equal to V Thevenin by R Thevenin. So, if you solve the Thevenin's equivalent, that this circuit, if you solve this circuit, right, you solve it, because now you know how to solve it, right. So, if you solve this circuit, you will get your I 3 is equal to I 4, I 3 will get 2 ampere, and I 4 is equal to 1.38 ampere. So, V Thevenin you will get 5 by 4, that is 6.923 volt. Therefore, I Norton is equal to V Thevenin by R Thevenin is equal to 6.923 by 3.007 is equal to 2.25 ampere. Similarly, here also we got I short circuit current, that is equal to your I Norton, right, because this is short circuit current, I n is equal to your I short circuit, that is your Norton current, right, 2.25 ampere. So, here also we got that your what you call here, using your same thing, that Thevenin your I Norton is equal to, basically it is short circuit current. So, basically it is a V Thevenin by R Thevenin. So, 2.25, and R Thevenin R Norton same, it is VOC by ISC, that means V Thevenin by short circuit current, here also 3.007. Just to verify this, the Thevenin and Norton are shown in this thing. So, this is actually Thevenin equivalent, right, and this is Norton equivalent. That means, if you divide V Thevenin by R Thevenin, you will get I Norton, that is 2.25 ampere, and R n is equal to 3.007 ohm. This is in parallel, and I Norton is equal to V Thevenin by R Thevenin. I hope you have understood this. So, basically Thevenin's Norton's transformation or Norton Thevenin's transformation, right, source transformation is. So, thank you very much, we will be back again.